Ever wondered how hospitals keep your medical data safe in our hyperconnected world? Here's a sobering reality. Healthcare's digital transformation is a double-edged sword. While it enables life-saving data sharing, it also makes these systems prime targets for cyberattacks. And here's the chilling twist. Hackers often have 14 days to exfiltrate sensitive patient data before detection. That's way too long. So how do we catch these intruders in real time? Enter a groundbreaking approach from researchers leveraging anomaly detection, a security mechanism that learns normal network behavior and flags deviations. But traditional methods, they're slow, resource-heavy, and ill-suited for today's high-speed, wireless medical networks. The solution? Field-programmable gate arrays, FPGA, reconfigurable chips that process data at lightning speed while consuming less power. Scientists engineered a system where FPGAs analyze network traffic in real time, acting as a digital sentinel. But how does this work under the hood? Let's dissect it. First, they employ network sketches, a mathematical technique that creates a compact, real-time snapshot of a hospital's network activity. Imagine a fingerprint of all device interactions, distilled into a lightweight summary. This allows the system to detect anomalies like a device, transmitting an unusual data volume, or mimicking a legitimate machine. Next, machine learning models take center stage. Some analyze flow-based metrics like packet rates, while others scrutinize raw packet payloads. The team tested both approaches, integrating them with FPGAs to balance speed, accuracy, and power efficiency. Here's where the innovation shines. They developed a comprehensive evaluation framework to test every possible combination of detection methods, hardware, and preprocessing steps. Think of it as a lab where they systematically optimize configurations. The result? A system achieving 21 Gbps throughput, enough to handle even the fastest 5G networks. Why does this matter? In healthcare, every second counts. This system could identify breaches as they occur, giving administrators critical time to respond before data leaks. Plus, its power-efficient design makes it practical for real-world deployment. Looking ahead, this research isn't just about one tool. It's about empowering engineers to tailor security solutions to any medical network, from small clinics to sprawling hospitals. In our digital age, this could be the shield we need. Thanks for watching. If you want to explore how networks stay secure, hit subscribe. Stay curious, and let's keep pushing the boundaries of AI and cybersecurity together.